So in the last example, we had an example where the YZ plane was the polar plane. This one is going to have the XZ plane as the polar plane. You'll see. So we're going to find the mass of the solids bounded by the sphere x squared plus y squared plus z squared equals 51, and the hyperboloid of two sheets, which is negative x squared plus y squared minus z squared equals 1. And of course, we don't know what that looks like off the top of our heads, so we will grab Maple and make it plot the 3D surface. And it looks like this. It kind of reminds me a little bit of Princess Leia in the first Star Wars movie, A New Hope. So you have this sphere, and you're kind of ignoring the sphere part, and you only want the part over here on the right that's inside these objects, right? Inside this hyperboloid of two sheets, but also inside that sphere. So it's really like knowing that one thing on the head and the other thing on the head, right? So if you can imagine Princess Leia in that first movie, you want to know the part of the hair that's on the two sides of the head. That's what you're looking for, right? All right, so we have to draw that. Let's see what we can do. And then we also have to kind of make some ideas about all of this. So we'll notice that this is a sphere, right? And the reason we want to, if in case you missed it, let me just go back real quick and look. So we want to use this piece as our as one of our integrations, and the easiest way to solve that one is for y equals, because y is the part that's positive. And so because of that, that means that we're going to be using, actually, let me do this one first. So this is y squared equals 1 plus x squared plus z squared. So that means I want to make that into r squared. So that means that y squared is 1 plus r squared. So we are doing the xz plane is the polar plane. And then all the things that come with that, right? It'll be x equals r cosine theta, z equals r sine theta. It'll be y equals y, and then x squared plus z squared equals r squared. And I'm going to use that piece, right? So if xz is the polar plane, then all of these things are true, right? And then that means my sphere is really y squared plus r squared equals 51. So y squared is 51, take away r squared. So y is plus or minus the square root of 51 minus r squared. All right, so there's those objects. That's the hyperboloid, or excuse me, that's the sphere, and this is the hyperboloid. All right, so let's draw that. So, and it's not actually going to be that hard to draw. We just have to draw a sphere. Right, so there's our sphere. There it goes. And then we have to draw the hyperboloid on top of it. So the hyperboloid kind of cuts in on one side, right? Kind of forms a ring. And then it cuts in on the other side. Right? And that's what we're doing, right? We're cutting off these pieces, and that's the part we're really interested in. Okay, so then we have to project onto the XZ plane. So here's the XZ plane. The projection of those objects, so if you look at them on Maple, you can kind of see it. If I look down the barrel of the y-axis, they're forming circles, right? So the region of integration is totally a circle, right? So it's forming the circle on the, right, there's a circle right here in the XZ plane, and that's your region of integration, right in there. Okay, so we're obviously not going to leave it like that. We're going to draw it here. Right, so this is the surface that I'm drawing here, and this is the region. Okay, so then the region of integration is like this. So what circle is it, is the question. So we have to set the two y values equal to each other. So y was equal to 1 plus r squared, but y was also equal to, or excuse me, y squared is equal to 1 plus r squared, but y squared is also 51 minus r squared. So let's find that intersection. So intersection. So y squared was 1 plus r squared, which was 51 minus r squared. So if I bring the r squared over and bring the 1 over, I'll get 2r squared equals 50. So r squared is 25, so r is 5. So this is a circle of radius 5. Again, technically it's plus or minus, but we ignore the negative because negative would just be over here, right? There's the negative 5. All right, so all of that is set up, all of it. So now we actually have to do the integral. Actually, I'll separate this. Okay, so we want to find the mass. All right, mass is the triple integral over the solid of some density function. In our case, it'll be of r theta y as our variable, and then r dy dr d theta, right? That's how we're going to do this. Okay, so mass is triple integral density. Density is solid, right? It tells us right here the density is 10. So great, I'm just going to put 10 in here. Then I'm going to send 10r and then dy dr d theta. I'm thinking about my color choices here. I think I'll go dy dr d theta. Right. Okay, theta is easy because we're going all the way around the circle. So theta goes from 0 to 2 pi, no problem, right? 0, 2 pi, once again. And yes, we will be able to use our trick yet again and pull that out in a second. Okay, now what about r? Well, r starts at the center, at the pole, and goes to where it hits that circle, which we found, it's 5. So 0 and 5. Now, where we're going to run into a tiny bit of trouble is the y values. So there's solids, plural. There's two sides to this Princess Leia head, right? There's the one on the right and the one on the left. And that is really difficult to set up. So, matter of fact, it's impossible to set up in one set of triple integrals. So, because there's two things going on. There's a positive side over here on the right, and there's a negative side over here on the left. But if you'll notice, they're identical. And our density was constant, so it's not like it's different from one side to the other. So we're just going to set up the integral for the right side and multiply it by 2. Haha. So we're just going to do this. We're going to go 2 right here. Symmetry, right? We're just going to do it that way. So now we have to think about stacking in a column. And I drew that in red, unfortunately, so let me grab like a different color here. So we have to stack in a column in here, inside that Princess Leia Danish on the side of her head, right? We got to think about a column in there. So where would it be going from? From what to what? Well, it's going from this outer portion, or excuse me, this red portion right here, which was the hyperboloid. And it's the positive side of the hyperboloid, right? So it would be y equals the square root of 1 plus r squared. Sorry, I didn't find that on its own, but let me do that. So this would be y equals the square root of 1 plus r squared. I got so excited about being in the xz plane for my polar plane that I forgot to do this. So r squared, right? So this is the negative one, but we're not going to use the negative one. You know, we have to make a choice here. And the positive one's definitely easier to work with. So we're going from that back bit, right? So that's inside right there, up until that sphere, because it has to be inside the sphere. So over here, we're hitting the sphere at y equals the square root of 51 minus r squared. Right? So if you look at the picture in Maple, you can kind of see it better. You're going from the red bit out to the aqua bit, right? There's a column stacked in there, right? So you're going in there. Okay, so then that means we're going from the square root of 1 plus r squared out to that sphere, which is the square root of 51 minus r squared. All right, so at this point, we're off to the races. There's no theta anywhere in any of this, so we're just going to bring 2 pi out, and there's already a 2 sitting here, so that's 4 pi, and there's a 10 here, so that's 40 pi. So let's just do that. So we're just going to write 40 pi, right? We're going to put a little crisscross on our thetas, right, to show that we did that, right? So those are gone. We made that disappear. It became 40 pi, right? All right, then I'm integrating from 0 to 5 for r, which I have not done, and I cannot do that trick because r is involved in here. So 0 to 5. And then I'm going to integrate this, just the r, because I already took care of the 10. Just the r with respect to y would be y, right? So we're going to take y from the square root of 1 plus r squared to the square root of 51 minus r squared, dr. And that, of course, just becomes this one minus that one. That's a 51. So that means we have 40 pi, integral from 0 to 5. Oh, and there's an r still sitting there, sorry. ry. So r times, and then it's the square root of 51 minus r squared, minus the square root of 1 plus r squared. And as per usual, when it gets that ugly, we are not doing that by hand. No, 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 no. We are going to make Maple do that. And that is what we have the big guns for. Right? This is not a Calc 2 class where we have to figure out how to do all that stuff by hand. So we are going to make Maple do it, which of course I already did. And it's right here. Ugly, ugly, ugly. so this is the original integral, right, as you can see. And it gave me that answer. Yuck. And I said, I want no part of that answer. I don't even want to have to write it down. So give me a numeric answer, please, and thank you. And it did. Now, this is only 20r. I don't mean only. I mean, this was 20r because I put the 2 times the 10 in. So you could have put the 20 out in front, or you can put it inside there, you know, whichever way, it's fine. And then I did it again with what I just came up with, which was the 40 pi times the r, and then square root of 41 minus r, 51, sorry, minus r squared minus the square root of 1 plus r squared. And then from r equals 0 to 5, and sure enough, it gave me that same answer, which is ugly. So I come up with 4191.46. Now, what about the unit? This is mass, right? Mass is the grams. The dV is the centimeters cubed, right? So this dV bit in the back, right? Because these are centimeters, centimeters, centimeters. So this is grams.